So this is the treatment system.
Yeah, that was a good guess. Doesn't look like it would be a standard treatment system because it certainly is not. It's something that I designed. I have a long time background in microbiology and study of algae and wastewater treatment, so I put together a long career in information that I gathered to design this little system.
So how does this whole system work?
Oh, how does it work? Okay, well, first of all, let me say that the application is if you don't have a farm and you have no use for the waste as fertilizer and you are forced to treat it somehow before you dump it into a river, that will be the application for this SaniMix system, because you could actually feed it the concentrated waste and it would treat that waste. Here, this, by the way, is only a model. It could actually function theoretically for maybe one of these little bird's nest things, but it's designed to actually show you the theory of how it works, rather than actually being something that's functional. This is where the feed, the raw feed, comes in and becomes diluted in this basin. The point of this is to dilute that waste. Okay, that's the first part of the system, is to dilute it.
Right.
So covering this thing up without oxygen, it will generate biogas. So that's just an additional advantage or benefit of this system. Okay, someone can step downhill, all flows by gravity. And this is a recycled material biotower. So what I've done is I've taken basically recycled and waste plastic materials and shredded it up and put it into this wire tower. And what it does is it recirculates the water many times, and as it trickles down through, it's very similar to a traditional trickling filter, except for there's two huge advantages. One is it's open to the air, so it's not going to be blocked up by growth. And the other is it's open to sunlight. So the fact that it's open to the air encourages the bacteria to grow. The fact that it's open to sunlight encourages the algae to grow. The benefit of the algae is that it sucks the nutrients out of that water, which is a big issue these days from sewage plants, as they put nutrients into the water. The point of the algae will be to take the nutrients out of the water.
And with all the recycled material and everything, I would assume it wouldn't cost a lot of money to build?
Exactly right. Yeah, the thing that I keep trying to come back to is the low cost. So a typical trickling filter will clog up. It requires a lot of energy to blow air through the bottom of it. This, open to the air, is exposed to its own oxygen source. It's just the moving air. The reason there's another one, this is called a cascade system. It's a SaniMix Cascade system. Let's go back to a trickling filter. They're assumed to be about 90% efficient in terms of removing the waste. BOD is a term for the strength of the wastewater. So it removes 90% of the BOD in your first trickling filter. Flow through is extremely low.
Right.
In a sewage treatment plant, you may have thousands of gallons per minute going through it.
Right, so that's kind of a waste of water.
Yeah, so actually it's a waterless system. There's no fresh water. Once these basins are full, there's no new water added to it. So you're putting 2 gallons a minute maybe, all depending on the size or the number of your little units feeding into it. That determines the flow.
Right.
Nothing else, no fresh water.
Right, wow.
So we're treating waste and not wastewater because we're not generating any wastewater.
Right, right.
I'm calling it a cascade system because, okay, this is 90% removable, leaving us with 10% waste value. Go to the next one, another 90% removal of that 10%, so now we're down to 1% in theory.
So all the waste
you can keep going down and down. Probably 3 would be a practical maximum. To repeat these things. And what happens is the bacteria run out of food, and which is the waste. And when they run out of food, the water is clean.
Right.
So that's the theory behind the whole thing.
Do you have to clean it at all? Like clean the filter?
Good question. These towers will eventually build up a heavy deposit of bacteria and algae.
Is that dangerous?
So, no, it's not dangerous, but what happens is you have to just shut it down. And the advantage of this open system is you can just hose it down, virtually hose it down with a water jet, and clean it, and let your solid materials drop off into the basins, and then pump that out from the bottom of the basin. Many times, an engineering company will go to the third world, put in a multi-million-dollar plant, leave, and the operators are left there not knowing how to run it, not having the way to repair it, or not really easily understanding how it works. So this is all very visual. So you can tell whether it's working or not just by seeing, okay, is it flowing? Is it flowing?
Right, right.
Are you getting the same amount of treated water out of it that's coming into it? Very simple to see that.
Right.
Okay.
Very.
So with modern plants, they're very often they have to be abandoned because they fail. This is not a system that's very easily likely to fail. Okay, so what we've seen here is a change in the basic approach to sanitation. We're getting away from very, very unpleasant and dangerous labor. We're using the materials or byproducts very soon. It's a whole change in the way that we may be able to approach sanitation. And another thing maybe I haven't stressed enough is that we have a liquid, we're not using any water. So water is a whole other issue in the third world, and waterborne diseases are basically drinking water which is contaminated by human pathogens. So we've gotten away from all of that. So here's a tangible effort, and it's worth trying out.